For this lab, I wanted to do a bit of a deeper dive on a previous lab of mine. So today, I'll be taking you back to Lab 2 for a bit. In my Lab 2, there was a bit of a difference between my experimental data and my model data, as I'm sure there was with everyone's. And I assumed that it was just some error in my tracker data due to my human error in selecting the points to track, because my auto tracker didn't work on like the white on white essentially. Um, but for this lab, I saw an opportunity to look into this a little further because of the open-ended nature of this lab. And I saw this as an opportunity to explore whether or not this reasoning was actually true. I thought it would be interesting to take a deeper dive into my differences in drag and hopefully give further insight into my exploration of Newton's second law of motion. I intend to learn and maybe teach you guys a little more about ways we can think about, handle, and explain error in our experiments, not only looking back, but also going forward in the future with any future experiments we may do. Uh, in the future, for me personally, I will hopefully be more equipped to think about error in my data as a result of this deeper dive that I'm doing. So I'll start off by providing a summary of my second lab. So here is my tracker video. As you can see, there's a tissue falling from rest, and the only two forces acting upon it we know are gravity and drag. We know this because we all did lab 2. And here is my code modeling the situation. Here's a code modeling it without drag. I'll run it real quick. So here we have it. And then here's my code modeling with drag. And here we go. And you'll see that the one without drag, the velocity isn't changing over time. Or rather, um, the change in velocity over time is constant. The velocity is changing over time because of the force of gravity, but this is changing at a constant rate, while with the drag, it's changing at a variable rate. It's approaching this constant value. And so now I'll take you into my Excel sheet where I've done a few calculations. You'll see that I calculated um, the drag force of both the model data with drag and the experimental data. And I used the dragless model to, um, as like sort of the basis of these calculations to sort of uh, kind of take away the gravitational force using the model force, which doesn't include the drag at all. And it's a bit of a backwards calculation, and to be honest, for the model data, I could have easily just used the GlowScript data, but I wanted to stay consistent for both ways of finding the drag, with the way I found the drag for both the experimental and the model data. And also I wanted to be able to use the values in the code as a reference to check my work. And so when we go down here, I calculated the average values of each of them and the difference between the average value of the actual drag force and the model drag force. And you'll see that it's very small. The difference is extremely small. And that's understandable when we look at the position versus time graph for these. It's very close. They're very close to each other. And just this alone doesn't tell us a ton though. This doesn't tell us, okay, where did this go wrong? Where does this difference come from? Why did this difference happen? And so I made a graph of the drag force over time over here. And you'll see that there are all of these spikes upwards and these big drops downward in the actual drag force. It's constantly spiking up and down and up and down and up and down in my experimental data. But for the model data, it's just this smooth curve going upwards. And so this gives us a much better idea, a much better insight, a much bigger picture as to what exactly went wrong. And so these spikes indicate that my initial assertion was correct. The initial assertion that it's due to my inaccuracy in the tracker data is correct because, as you can see when we watch the video, like ignoring the points, obviously the piece of tissue paper is not making spikes in any direction. It's a smooth travel downward. It's a smooth travel. It's an object in the real world. It's not doing all these spikes up and downward. And so, yeah, my initial assertion was correct. Thank you.